Hello everyone. I welcome you all for the lecture series videos of mechatronics and automation. I'm Dr. J.Yokesh, Assistant Professor of Mechanical Engineering. In this video, we are going to discuss about the velocity control. In the previous video, we have discussed about the digital control, how the digital systems can be accomplished, the function of DAC and ADC for the digital systems, and how the output being the function of the error signal, everything we have discussed. In this video, we are going to discuss about the velocity control, uh, where we are velocity being the critical parameters for a few applications. But before that, we have to clear idea about the velocity. So, what do you mean by velocity? So, velocity is the change of distance of any object with respect to the time. That is rate of change of distance with respect to the time. Usually, the unit for the velocity is meters per second. That is distance moved by the object with respect to the time. So the distance is in terms of meters and time in terms of seconds. So therefore, the unit for the velocity is meters per second. So many time velocity being the critical parameters where we have to control the velocity of any object uh, for the critical applications or any moving body. So in this video, we are going to discuss about how the velocity control can be accomplished. So this is an example where uh, we have an output that is output of the motor. Uh, the motor velocity we have to control. So for measuring the motor output, we have a gearbox and the load. The motor is connected with the gearbox and the load system. It is being the application. So for measuring the output for the motor is two outputs. One is speed and next is torque that is being controlled. So simultaneously, we have to control the speed of the motor and the torque of the motor. So for that, we have an comparator in the initial stage, which compares uh, the set point value of speed and torque. For measuring speed and torque, we have a speed sensor such as an encoder, so which encodes the signal or which produces the output signal that being the function of the speed. And the next is the torque transducer. It is being the function of the spring loaded systems. So the amount of displacement is being the function of the torque produced in the systems. So both the signals can be compared in the comparator where we can compare the uh, systems in the comparator. So these things are compared in the torque comparator. Once it is compared, if there is any deviation, then it is sent it to the SCA controller where it is a system of error can be controlled and it is sent it to the speed controller. The speed controller, again, we have a summation. The first comparator compares the torque and the second comparator compares the speed. So if there is any deviation, that signals is sent it to the speed controller where speed controller compares the value and if there is any deviation, then it is speed being controlled by the motor. The adjustment of the speed is signal is sent it to the motor, and both the adjustment of speed and torque can be varied in the motor by varying the electrical parameters, that is voltage and current. So this is how the system is functioning in the velocity control. And this is the detailed diagram for the velocity control. The same thing, we have two summing amplifiers. One is for position measurement in this case, and another one is for speed measurement. In the previous case, we just compared for speed and torque, and in this case, we have comparing for speed and position. Once if there is any deviation, both the deviations are sent it to the servo amplifier, which amplifies the signal because the signal is very minimal from the summing amplifier. So we need to amplify the signal, then amplifies the signal is sent it to the motor. So the motor being controlled the speeds and the position, and the speed can be easily measured with the help of speed measuring devices, and the position can be measured by means of position transducer. And these are all the references for my presentation. One is Mechatronics authored by Bolton W. Uh, Published by Pearson Education in the year of 1999. And the second reference is Mechatronics authored by Bradley, published by Chapman and Hell in the year of 1993. So in this video, how the velocity control can be accomplished, we have discussed. So thank you for watching this video. Thank you.